All right, so we have here a lumbar vertebrae, thoracic vertebrae, cervical vertebrae, C2, otherwise known as the axis, and C1, otherwise known as the atlas. And just from first glance, you can already tell that the cervical, thoracic, and lumbar vertebrae all look quite different. First of all, there's the size. And then second of all, if you look from the side, you can see that the lumbar kind of looks like a moose. You can see that the thoracic kind of looks like a giraffe. And then cervical looks a lot more flat, and it also has this transverse foramen, which goes through the transverse process, which is unique to the cervical vertebrae. But let's start identifying some structures on the lumbar vertebrae. Now, these pretty much stay the same for the whole vertebral column. The only place where this isn't true is for C1 and C2, and we'll go over that later. And it'll be the same colors throughout. So we have the body in the front, which is green here. We have the spinous process in the back, which is red. You have the transverse process, which is pink. And then you have the pedicle, which is brown here, connecting the body to the transverse process, and the lamina in blue, connecting the spinous process to the transverse process. You also have a superior articulating process, purple, inferior articulating process, purple. And each of these has a facet, this orange place. And the orange is where the articular cartilage sits, and this is where you actually get the connection above and below. So you can see this lumbar vertebrae sits above, and they connect like so. And the facets touch. So here you can see the facets. All right. So the other thing that you have is a notch. So you have a superior notch and an inferior notch. And this notch, you can see right here, that is what forms half of the intervertebral foramen. So when we stack these together again, you can see how there's a hole in between the vertebrae that allows spinal nerves to exit. And that intervertebral foramen is very important because that's where herniated discs can impinge on our spinal nerves and then cause a whole bunch of pain. So we have a superior notch, inferior notch, a body, superior articulating process with a facet, inferior articulating process with a facet, spinous process, a lamina, and a pedicle. These structures are all the same on the thoracic. They just look a little bit different. And the cervical. They just look a little bit different. Slightly different shapes. However, with cervical, as I mentioned before, you do have that transverse foramen. Now, here we have C2, otherwise known as the axis. I think about it as the axis. The way I remember that is because I imagine a globe spinning over this point. Like you can imagine a globe spinning over this axis. And this thing that's sticking out right here, it's called the dens or odontoid process. And what this does, when you see it connect with C1, what you see is that this structure is designed so that you can get a ton of rotation. You can see that. And why that's important is because 50% of the rotation in your cervical spine comes from this joint, from C1 to C2. And if that is limited, then you can have a really big deal. So you can have a really big increase in function if you target this joint. Additionally, people with rheumatoid arthritis and Down syndrome often have trouble with the ligaments that connect to these. And then they become actually too loose. And then you have the opposite problem. There's too much motion in the area. And then you can get spinal instability and a whole host of other problems that we see and need to treat as well. So other than the dens, things stay pretty much the same. We still have a body, although it's better seen from the bottom. You still have a transverse process. You still have a pedicle, although it's small here. You still have a lamina, spinous process, superior articulating process and facet, inferior articulating process and facet. Now we got the Atlas. So Atlas in Greek mythology is the titan that holds up the world. And from here you can see that this one is quite a bit different. It doesn't look like most of the others we've seen, and that's because it is different. It doesn't have a body. Instead, it has an anterior arch. It doesn't have a spinous process. Instead, it has a posterior arch in blue and a posterior tubercle here in red. Additionally, it has this extra facet. This is the facet for the dens. So you can see when they stack on top of each other, bring this up, they line up very well. So you have anterior arch, posterior tubercle, facet for the dens. you have a lateral mass. So this brown, instead of it being a pedicle, it's the lateral mass. You do have a transverse process, and you do have an inferior articulating process and facet. But on the top, this is called the occipital condyle because we're not connecting to another vertebrae, we're connecting to the head. So it gets a new name change. So just to go over all that again, anterior arch, facet for the dens, posterior arch, posterior tubercle, occipital condyle, and facet, transverse process, transverse foramen, posterior arch, posterior tubercle. I hope that was helpful, guys. Let me know if you have any questions in the comments. Thank you all, and have a nice day.